All right, so welcome to the video on more probability. So in this video, we'll be doing just a little bit more of probability, and we're gonna be talking about mutually exclusive events. So two events are mutually exclusive if they do not share any outcomes, so if there is no overlap in them. What do I mean by that? So I'm gonna give you two examples, one of which is mutually exclusive and one is which is not mutually exclusive. So let's look at this first one right here. Drawing a 5 out of a deck of cards, drawing a 5 versus drawing a 7. So there are 4 cards that have a 5 on. There's the 5 of hearts, there's the 5 of diamonds, there's the 5 of clubs, and there's the 5 of spades, all right? Now there's 4 cards that are 7s. I'm gonna copy and paste this so I don't have to draw those symbols again. There are 4 cards that are 7s. There's the 7 of hearts, 7 of diamonds, 7 of clubs, and 7 of spades. But there is no overlap. There is no card that is a 5 that is also a 7. So these two events are mutually exclusive. There is no overlapping overcome. There is nothing that is true about both. There's nothing that fits into both of those. There's nothing in this area right here. Now, if you're like, what? This is an example that is not mutually exclusive, and I think it's easier to make sense of mutually exclusive when you see not mutually exclusive. So if I wanted to look at a deck of cards and I said, which cards are aces versus black cards? So if you think about a deck of cards, there are 4 aces in a deck: the ace of hearts, the ace of diamonds, ace of spades, ace of clubs. And then there are 26 black cards in the deck. Half of the deck is black cards. There's 52 cards in the deck, and half of them are black, all right? But within those black cards, 2 of them are aces. It's the ace of clubs and the ace of spades. So the ace of clubs and ace of spades fits into both of these categories. So they are in that overlapping area, ace of clubs and the ace of spades. They fit into both categories. So the 4 aces, I can write out the hearts and diamonds here. There's 4 aces. There's 26 black cards. I'm not going to list the other 24 black cards. I'm just going to write 24 other black cards. But there is an overlap in black cards and aces, and that's the ace of clubs and the ace of spades. So these two events are not mutually exclusive because there is an overlap. There are cards that are aces and black cards. Okay? All right, so we will be looking at mutually exclusive events and events that are not mutually exclusive. First, let's start with a little bit of notation. We've already seen this, but this right here is the probability of A. So that's the probability of event A occurring. So the probability of green marbles, the probability of, and like you just, whatever that first event is. This is the probability of 2 events, and this is a symbol right here, which is intersection. And that intersection means and. So let's write that down. That symbol is intersection. And it means and. So it's the probability of this and that. Okay? A and B happening at the same time. This symbol right here, which we have seen before, is a union symbol. And that means or. So that's the probability of event A or B happening, okay? So once again, intersection is A and B happening, A and B, I should emphasize that, happening at the same time. And then probability of probability of A union B is the probability of events A or B happening, okay? Looking at our first example, if 2 events, which those 2 events were mutually exclusive, then the intersection of A and B is the empty set. So this right here, there's nothing there, so it is the empty set, which we can write like that. Okay, the probability of the union of 2 events, so that is the or events. The probability of A or B happening is given by, you're gonna take the probability of the first event, add the probability of the second event, but then you have to subtract the intersection. Let's look back at that non-mutually exclusive event right here. So if I want to know the probability of choosing an ace or black card, I can take the probability of choosing an ace, which is 4 out of 52. The probability of choosing a black card, which is 26 out of 52. But now I've counted the ace of clubs and the ace of spades twice, so I have to subtract the probability of a black ace, which is 2 out of 52. And that's how you'd get the probability. And that's what it says to do here. Take the probability of event A plus the probability of event B and then subtract the intersection. Now, if the events are mutually exclusive, there will be no intersection, so you don't have to subtract that off. Okay, so I just took the time right here, not took the time, but I stopped a video and went back and got this deck of cards just in case you're not familiar with what a deck of cards looks like, so I don't have to say picture it in your head, but that's what our deck of cards looks like, okay? All right, so we're gonna find the probability that let's start off with one card is selected from a standard 52 playing cards. So we're gonna pick one card from here. What's the probability that it is red and a faced card? So we want the probability of red intersection face card, all right? Red and a face card. So it has to be red and a face card. This is different from red or a face card, which is the next problem. So we're looking for any red face cards. So if you look here, there's 3 here and 3 here. So there's 6 total, and that's 6 out of 52. We're going to turn that into a decimal. I have my calculator off to the side right here. So that decimal is 0.11538, and then we will turn that into a percentage. So 11.538%. If you automatically turn it into your your percentage with 3 decimal places, I'm fine with that. Yeah? Okay. So next it says, what's the probability that the card is either a red card or a face card? The probability of this should be higher because there's red, it could be red or a face card. It doesn't have to be a red face card, right? So this does have overlap. This is not mutually exclusive. There are red face cards, so we have to remember to subtract that off. So we're gonna do probability of red union face card, which is red or, and this is and, all right? So to do that, we're gonna take the probability that it is a red card. We are going to add the probability that it is a face card, and then we are going to subtract any red face cards. That's my red face card rating, like that. Okay, so probability that you are going to choose a red card, that is half the deck, all right? So out of 52, there's 26 of them. Plus probability that you would choose a face card. So if you look here, there are 12 face cards. They're all right here, all right? But now we just counted these 6 twice. So we have to subtract any red face cards. So 6 out of 52. And then we get a common denominator of 52. 26 plus 12 minus 6 is 32. And then I'm going to turn that into a decimal. 32 divided by 52 is 0.61538. So 61.538%. So much more likely to choose a red or face card than to choose a red face card. Makes sense? All right, next we're talking about a dice. I said die, but dice. A dice. A standard 6-sided dice is rolled. No, it's die. It's a standard 6-sided die is rolled. What is the probability that the die will come up an even number or a multiple of 3? So we're going to do the probability of an even number or, which is union, a multiple of 3. So multiple of 3. All right, so I need to do the probability that I'm rolling an even number plus the probability that I'm rolling a multiple of 3, and then I need to subtract if there's overlap, right? So are there any even numbers on a die that are multiples of 3? Yes. So I need to subtract the probability of even intersection multiple of 3, right? All right, so probability that it is even. So there's 1, 2, 3, 4, 5, 6, 2, 4, 6 are even, so 3 out of 6. And we don't want to put a simplified fraction because then we would have to get a common denominator. So we always keep our unsimplified fractions until the end. And then multiples of 3. So once again, 1, 2, 3, 4, 5, 6. 3 and 6 are multiples of 3. So there's 2 of them. But then did I say any of those numbers twice, right? So the even multiples of 3, 6 is an even multiple of 3, so I have to subtract that off because I counted it twice. I counted 2, not 3. I counted 2, 4, 6 here, and then I counted 3 and 6 here. Why can't I write 3 and 6 here? So I have to subtract this because I counted it twice. I have to subtract one of them, not both of them. All right, so now it's an eraser. So now I have 4 over 6, 2/3, which is 0.666666. And that is 66.667%. Okay? So if you looked at it differently, you're like, oh, okay, what if it said probability of even and a multiple of 3? That's this, 1 out of 6, right? Okay, so now what I want you to do is pause the video. I want you to try, at the very least, these ones right here before you leave this screencast because I'm going to show you the answers. All right, here they come. Hopefully this is enough. Let's see. If not, I can fix it. Style. Let's bring that back to life. Oh, there she is. All right, here are your answers to these. This was mixed practice that isn't necessarily exactly like what we just did. It comes from the stuff that we've done in, the days before. Person draws 2 cards from a deck. So if I'm drawing 2 cards, I can't do my over 52 over 52. I have to do my denominator is 52, choose 2. What's the probability that the 2 cards drawn will both be face cards? So if you look, face cards, there's 12 of them, and you're choosing 2. So your numerator is 12, choose 2. What just happened there? I didn't undo it, did I? There we go. Next, bag contains 4 red, 3 yellow, and 5 marbles. 2 marbles are selected from the bag. I wrote down that there's 12 marbles total because it's saying that you're selecting 2. So your denominator is 12, choose 2. The first one is, what's the probability that both of the marbles are green? So there are 5 green marbles and you can choose 2, right? So 5, choose 2 for your numerator. And then what's the probability that at least 1 marble is yellow? So that is 1 or 2 yellow. So the probability of choosing 1 yellow is 3, choose 1. But then you have to choose another marble out of the remaining 9. So that's 9, choose 1. Since it's or, we're adding. And then 3, choose 2 would be the probability of choosing 2 yellow. So out of the 3, not probability, the ways you could choose 2 of those 3 marbles. Okay, and then put that in your calculator, and that's what you get. The rest of it is on here, but I don't want to waste the time of the screencast to keep showing you all the answers. So the answers to those are in Schoology. You can try those on your own and see how you did.